So the next what we see in case of the different kind of solution is the saturated and unsaturated solution. So next over here will be saturated and unsaturated. So first of all, let us see unsaturated solution. A solution which can dissolve more of the solute at a given temperature is called as unsaturated solution at that temperature. Let's understand this thing in a proper manner. I take a glass of water, let's say 100 ml of water. I take some 5 grams of salt, add to it, stir it, it disappears. Take some 5 more, stir it, disappears. 5 more, stir it, disappears. So till the time I keep on adding the salt, and if the salt disappears, that means the salt gets dissolved in that particular 100 grams of water or any quantity of water, then that particular solution which is formed is unsaturated. That means it has the capacity to take some more amount of salt in it. So it can take some more amount of solute in it. The solvent का capacity वो solute को digest करने का या तो dissolve करने का ज़्यादा है. So it, when a particular mixture, the particular kind of a solution is such that it can take some more amount of solute in it without any change in temperature. Now why temperature is involved is because when I increase the temperature of certain solvents, those solvents will have more intermolecular spaces and hence they will be able to dissolve something more than what is possible for them to do. And this we very well know that when we try to dissolve some sugar in a particular water, अगर वो ज़्यादा जल्दी डिज़ोल्व करने है तो हम लोग क्या करते हैं, उसको हीट करते हैं. तो हीट करते हैं तो वो फटाफट से वो डिज़ोल्व हो जाता है, राइट. सो यस, द dissolving capacity, okay, the solubility, which is called as solubility, okay, dissolving capacity of the solvent is nothing but the solubility of the solvent. So that particular solubility of the solvent is going to increase with the increase in temperature. So that's why we are considering the temperature to be constant. If at a constant temperature, that is a room temperature, if I am able to add some more amount of the solute to the solvent to form the solution which is still a true solution, then that particular solution is called as a unsaturated solution. So we define unsaturated solution as a solution which can dissolve more of the solute at a given temperature is called as unsaturated solution at that temperature. Okay, so I'm having a particular glass, I'm adding some more salt, I can still add some more salt to it, then that particular solution is the unsaturated solution. So of course what will be saturated? Opposite to that means I am not able to add any more salt into it. So if it so happens that when I add any further salt into that water and I find that even on repeated stirring and stirring and stirring, still that salt remains inside that thing and settles down, that means that it has lost its capacity to absorb more amount of salt in it, and hence that particular solution does not have any further capacity at that temperature to take in more solute molecules in it, and that solution becomes a saturated solution. So a saturated solution is a one in which you are unable to add any further amount of solute in that solvent. Okay, any further amount of solute if you add, it is not going to get dissolved. If that is the condition what is going to happen, then we call that particular solution to be a saturated solution. So we define saturated solution as a solution which cannot dissolve more of the solute at a given temperature is called as a unsaturated solution at that temperature. Okay, so it is not about allowing to dissolve any further solute in that solution. So saturated solution can be converted into unsaturated solution. It's very obvious. I can easily convert a saturated solution into unsaturated solution. Okay, how to do it? First is by heating the saturated solution. If I heat the saturated solution, the intermolecular particle space increases, and due to which more amount of molecules of the solute can get into that thing, and hence the solution can become unsaturated, means it can take, and if they increase the temperature, it can take some more amount of solute into it. So when I am heating a particular solution, then that particular solution or solvent, that particular solvent will have more additional space available to it for taking some more amount of solvent. So this way we see that I can convert a saturated solution into an unsaturated solution by heating it. So by heating the saturated solution slowly, a saturated solution can dissolve more of the solute at the higher temperature. So this is of course why slowly, because if I do it very rapidly or strongly, then the water, that the solvent would itself evaporate, and the quantity of water will also decrease, or the quantity of solvent will decrease, hence not making it unsaturated. And second method, very simple, add some more solvent. So that is adding more solvent to the saturated solution. So suppose you have a saturated solution and you want to make it unsaturated, just add some more water to it, so automatically it will become unsaturated. So increasing amount of solvent can dissolve more of the solute at the same temperature. So that's why we can have this method of converting the saturated solution into unsaturated solution. Then we have something which is called as a supersaturated solution. Supersaturated. As such, the term itself is self-explanatory. Supersaturated means something more than saturated, right? So if a particular solution is such that the amount of solute present in the solvent is more than the capacity of the solvent, then automatically it will be a supersaturated solution. So we have got this supersaturated solution as it is one which can hold or contain more of the solute at a given temperature than present in the saturated solution. So the amount of the solute present, if it is more than that of present in a saturated solution, is called as a supersaturated solution. We can have the preparation of the same. So a saturated solution of a solute, that is, for example, we are taking as a niter. So niter is the example they have taken over here. So they have taken niter and is prepared in boiling water. If this above solution is cooled, excess niter separates out from the hot saturated solution. The hot solution therefore contains more of the solute dissolved in it than it can hold at that given temperature, and is thus called as supersaturated solution. So this is how you are just going to heat it, and that heated one, you are just going to make that heated one into saturated one. So when it is going to be there, it is going to be a supersaturated solution. So the above solution, so when it is boiling water, it is cooled. So when it is cooled, the whole thing is not going to be coming out as a crystal, but it will be retained by that particular water in a certain measure. So that measure, what will be retained inside, will be more than what is present in the saturated solution. So that's why the amount of the solute present in the solution which is prepared by boiling and then cooling will be more than the saturated solution. Hence it is called as a supersaturated solution, as that hot mixture solution therefore contains more of the solute dissolved in it that can hold at a given temperature. So that's why it is a supersaturated solution. Exceptions over here. With certain substances, Na2SO4.10H2O, it is possible to cool a saturated solution without excess solute crystallizing out, provided no undissolved solids are present. So, yeah, this is an exception that Na2SO4.10H2O, that is sodium sulfate, it is possible to cool a saturated solution without excess solute crystallizing out. So as I told you, normally what would happen is that when you are going to cool it, the excess of the solute is going to crystallize out and it is going to give you a normal saturated solution. But this Na2SO4.10H2O, it is not going to give you the crystalline form and it is going to form into a supersaturated solution, so without being too hot. So accordingly, we have certain kinds of solvents other than water which are useful in our day-to-day life. So these are, first one, benzene. It is used to dissolve rubber. And next is turpentine, which is used to dissolve paints and paraffin wax. Then we have got carbon disulfide, which is used to dissolve sulfur and phosphorus. Petrol, which is used to dissolve grease, chlorophyll, rubber. Acetone, which is the nail polish remover that is used for dissolving cellulose acetate. Alcohol, it is used to dissolve iodine, naphthalene, chlorophyll, etc. And oxalic acid is used to dissolve rust. And methylated spirit is used to dissolve chlorophyll. So these are the things which are used for dissolving certain substances. And they have got a daily use also. So like for example, the one like petrol, kerosene, ammonium solution, they are used in laundries and dry cleaners. They use them to remove the grease stains. Turpentine is used to removing the paint stains, and benzene Bonex is used to remove the coffee and the tea stains. So to remove the stains of certain kind of chemicals, you require certain kind of solvents. These solvents are going to be not water but other than water. You're also using manufacturing of perfumes, aromatic oils dissolved in alcohol. Then for extraction of chlorophyll in laboratory by boiling the leaves in alcohol. So we boil the leaves in alcohol to get chlorophyll in laboratory. And in dressing in dispensary, dressing the wounds in dispensary, you are taking iodine dissolved in alcohol, which is also called as tincture iodine. So the red color दवाई जो normally wounds के ऊपर लगाते हैं, जब हम कहीं पे कुछ लग गया रहेगा तो wound के ऊपर जो red करके दवाई hospital में लगाते हैं, तो that is nothing but tincture iodine, that is dissolving iodine in alcohol. So that was about the different solvents. We now move forward to the solubility of as a topic, that's solubility. So how do we find out the solubility of substances, or what is the solubility of substances? That is what we are having in the next part. So different solutes dissolve to a different extent in the same mass of solvent. That is, they have different solubilities. It's not going to happen that if I got 100 grams of water, 100 ml of water, and I take salt, NaCl, then only let's say 30 grams is dissolving in it. If I take sugar, तो वो भी 30 grams ही रहेगा. If I take something else, वो भी 30 grams रहेगा. ऐसा नहीं है. Each and every salt or each and every solute has got a different kind of solubility in water. So that amount of the solute which can get dissolved in that quantity of solvent is the solubility of the substance. So that's why you see that solubility is the ability of a solute to dissolve in a particular solvent. The ability of the solute to dissolve in a solvent is the solubility. So to obtain a uniform result, the amount of solvent is fixed at 100 grams. So because every time we cannot change, अच्छा ये 100 grams नहीं है तो इतना होगा, पर ये 200 grams है तो इतना रहेगा, नहीं. What we are doing is that to have a uniform kind of a calculation possible, we always consider that the solvent to be taken for the checking of solubility to be 100 grams. So we'll take 100 grams of water and we'll take different salts, and we will check that how much quantity of salt is getting dissolved in that 100 grams of water. So the solution would be saturated at a particular temperature. So what we are going to have will be that solubility is the ability of a solute to dissolve in a particular solvent. To obtain a uniform result, the amount of solvent is fixed at 100 grams and the solution should be saturated at a particular temperature. So they always see to it that you are going to see whether it is getting saturated at a particular temperature or not. So let's start with the definition. Solubility of a solute in a solvent at a particular temperature is the maximum amount of solute in grams that will saturate 100 grams of solvent at that temperature. So solubility of a solute at a given temperature is the amount of solute. Okay, it's the amount, that is the grams of solute, or the maximum amount of solute in grams that will be saturating, that will saturate. Okay, so it is that much quantity of grams of that particular solute which will saturate 100 grams of solvent at that temperature. So that's why they are given over here. Solubility of the solute at T degrees Celsius will be given as weight of the solute upon weight of solvent. So we have solubility over here as solubility is equals to weight of solute upon weight of solvent. Now both these weights are in grams. So if you take this as 100 grams solvent into 100, so automatically what will happen, this we already taken as 100 grams. So 100 grams into 100 will get cancelled. So automatically it will be this way. Or we can also say it is equals to weight of solute upon weight of solution minus weight of solute. So if you don't know the value of the solvent taken, then we can take the weight of the solute upon weight of solution minus weight of solute. So into 100 will give you the solubility of that particular substance. So to determine this, it's a very simple process. We are going to take preparation of a saturated solution. So you take a boiling tube half filled with the water, 100 ml of distilled water. Add crystals of potassium chloride to the distilled water and stir slowly. Continue stirring till the crystals dissolve. Repeat the process till no more salt can dissolve. Pour the saturated solution in the clean test tube. Weigh the clean and dry evaporating dish. You take a evaporating dish, weigh that thing, that is your M. Add the above saturated solution into that disc, okay, and then weight, that will be M1. Heat the solution to dry as shown in the figure. So then you are going to heat it. So what will happen? The solvent is going to evaporate and the solid is going to remain. So that will be the next weight, that is M2. So now what you have got is weight of the solution you have got. After evaporation you get the weight of the solute. So weight of the solute is already known. Weight of solution is known. Weight of solute is known. Accordingly we have the solubility will be M2 minus M1 upon M1 minus M2. M2 minus M. M2 minus M is nothing but weight of the clean dish. We had taken the dish also. The dish ka bhi weight ginna hai. So automatically weight of the dish with the weight of the dish with the solute after drying, that is M2, minus M, that is the weight of the dish. Okay, I'll write it down. M, weight of dish. M1, weight of dish with solution. M2, weight of dish with solute, that is after evaporation or vaporization. So then we have got over here weight of solute. What is weight of solute? This minus this. So that is M2 minus M. And what is the weight of the solution minus weight of solute will be how much? That is nothing but weight of the solvent. What is the weight of the solvent? Weight of solvent will be solution minus solute. That is M2 minus M1 into 100. That is solubility. Got it? So that is at T degree Celsius, the solubility. You do not have any numericals of this, so this is just for your understanding. We next see is the solubility curves of the different substances. I'll just check. Yeah, you can go ahead. Now, if you see the figure over here, that is this particular graph, very, very important graph. Because what is this graph about? The graph is the way a particular salt behaves when there is an increase in the temperature. So here on one side, you have got the solubility, and on the other side you have got the temperature. So, like for example, we take the example of NaCl. So NaCl, so this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And here temperature also 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. For NaCl, it is seen that original oxygen is 36. So at 0 degree Celsius, if I take water at 0 degree Celsius, I can dissolve 36 grams of NaCl. And on increasing the heat temperature even to 100 degree Celsius, it is almost remaining the same. So it's just hardly around 40. So there is no difference. So this is for NaCl. NaCl is hardly any difference in the solubility of the substance with the increase in temperature. That is, NaCl has got a very, very minute difference or change in the solubility on increase in the temperature. You can have another example which will be, let's take it as Na2SO4.10H2O. So Na2SO4.10H2O is showing that it has got the Na2SO4.10H2O, yeah. So it is like this, somewhere near 10 and above, it goes here, and at a temperature of around 30 के आसपास में, it just sharply goes upwards. Okay, there is a sharp thing which is going upwards, it is here like this, and then at a particular 50 mark, it just dips down like this. Okay, that is for Na2SO4.10H2O. You don't need to remember all this, you just need to take some examples what we are just going to see over here. Then you have got KNO3. KNO3 is going to be like shooting up, so that will be like starts from somewhere near here, and then by the time it reaches 80 degrees, it is just gone up to the 100 point. So that's going to be like this one, this is KCl, so KNO3. Potassium nitrate is going to be like this. KCl, there is only very small increase. There is one which is going to go decreasing, so I just find out what is the one which is decreasing. CaSO4, where is CaSO4? They not mention that thing, but it decreases about 70 degrees. So yeah, so the curve, you can just go through this curve, right? But the main thing which is written over here is important. So let's see what is there. If the solubility of a solute is in a given solvent are plotted against the respective temperatures, a graph showing the effect of temperature on solubility of the substance is obtained. This graph is called as the solubility graph curve or solubility curve. Qualitative effect of temperature on solubility: solids whose solubility increases in rise in temperature are KNO3, other example KClO3, NaNO3, CaUSO4, NH4Cl. So these are the ones which increases with the temperature. Highlight over here will be KNO3. Potassium nitrate, the solubility increases sharply on the increase in the temperature. That is KNO3. Increases slightly with rise in temperature, NaCl. Example will be NaCl. There is a very minute, other NaCl. Other than that, KCl, CaOH twice below 70 degrees, they are the one which are going to be having a very minute, a very slight increase in the temperature. Decrease with increase in temperature is CaSO4. That is, other example will CaOH twice, they are above 70 degrees. CaSO4, important thing, CaSO4, calcium sulfate. When the water, that is the solvent, is heated, it decreases the solubility. Means instead of having more amount of calcium sulfate available over there, there will be less amount of solubility of that thing. Next is Na2SO4.10H2O shows a solubility curve with a sharp break at 36 degrees Celsius. It is hydrous below 36 degrees and anhydrous after that temperature. So here, this temperature, this one, Na2SO4.10H2O, till 36 degrees Celsius, it is hydrous, means it has got the water of crystallization in that. But as soon as it crosses 36 degree temperature, the water of crystallization goes off. So since the water of crystallization is lost, after that there is a kind of no change, there is a sharp break in the solubility curve. KNO3 has the highest solubility at 100 degrees Celsius, and solubility of solid is independent of change in pressure. So solubility has nothing to do with pressure. So solubility of solids is independent of change in pressure. So that is how solubility will be different from pressure. Now we see the applications of the use of the solubility curve. So we see over here, first one, medical uses. Enables a pharmacist to determine the amount of drugs, solid solute, that must be dissolved together in given quantity of solvent at different temperatures to give a prescribed drug preparation. So you find always that the medicine what is being made, it has got so many different ingredients in it. So each and every ingredient we need to know that what is the solubility of each and everything. Accordingly, the medicines are prepared. Depending on that, the amount of solvent is added to it. So any syrup what we take in, okay, any kind of the syrup what you are taking for cough and cold. So that particular syrup, they will be having a particular quantity in it. So why is that particular quantity? Because it has got that particular amount of solvent, so that the solute which is present inside is dissolved in it properly. Chemists and research workers enable them to determine the most suitable solvent to be used at various temperatures for extraction of essential chemicals from the natural resources. So from the natural sources, the chemists and research workers are able to extract the maximum amount of things, because they know that what will be the temperature at which it is going to be saturated, and then it is easy to remove that thing. So separation and purification of solutes. When a saturated solution of a given mixture of a solid is cooled, those fractions with very low solubility will be the first to crystallize out from the solution. We had learned this thing earlier in the 8th standard, how crystallization or fractional crystallization is taking place. You need to remove, or if you want to separate a mixture of the solutes, then the solutes can be separated out by the different kinds of solubility of the substances, and fractional crystallization is going to take place. Summing it up, the solubility curve can be used to determine solubility of the given solute at a particular temperature, to compare solubilities of different solutes in a solvent at a given temperature, and to calculate the amount of substance which will crystallize out when a hot saturated solution is cooled to a lower temperature. So that is the applications of the solubility curve. Okay, we see the next part, and that is the solubility of gases influenced by pressure and temperature. Now we just read that the solubility of solutes is solids is not dependent on pressure, but yet it was dependent on temperature. But when you talk about gases, then the gases are going to be, the solubility of the gases is going to be affected not only by the temperature but also by the pressure. So here an increase in pressure on the surface of water causes increase in solubility of the gas in water. Now this is quite simple to understand by the simple kind of a example of a soda or the thumbs up or aerated drink what you want to drink. So that soda and all, if you see that the moment you open the cap, then the bubbles of the carbon dioxide is going to start coming out. So what is that? Because the pressure, when the whole bottle was under pressure, the carbon dioxide was dissolved inside the water. Do you see, if the cap was not open, do you see any kind of bubble formation inside the cold drink? No, you don't see any bubble at all. But as soon as you open the bottle, you will find that the bubbles formation start, because the bubbles are coming out because the pressure inside the bottle has decreased. So that is why when you open it, it opens with a fist. Why the open fist opens with a fist? Because it's under pressure. So when you are opening it, the pressure is getting released and the fist sound is heard. So solubility of gas in water at a fixed temperature can be correlated with the following law, that is Henry's law. At any given temperature, the mass of gas dissolved by a fixed volume of liquid is directly proportional to the pressure on the surface of the liquid. So yeah, it is the mass of the gas which is going to be dissolved in the water or the solvent will be directly proportional to the pressure. More the pressure, more the solubility, lesser the pressure, lesser the solubility. Evolution of gas is seen when a bottle of soda is open. That is what exactly I told you. Soda water contains carbon dioxide dissolved in water under pressure. Solubility of carbon dioxide under normal atmospheric pressure is very low, but when subjected to high pressure, it dissolves to great extent, as in the case of soda water, in which carbon dioxide is dissolved in water under pressure and the bottle corked. On opening the bottle, the gas rapidly bubbles out. Since the pressure on the surface of the water suddenly decreases, and so does the solubility of the carbon dioxide gas in water. So the pressure increases on the surface of water, its boiling point increases and freezing point decreases. The next is effect of temperature. So when the next thing is effect of temperature on the solubility of the gas in water. An increase in the temperature of water, the gas decreases its solubility. Now this is very important. When you are going to heat certain thing, on heating, the gas will be much more kinetic energy present in it. So as you heat it, the gas which is dissolved inside is going to start coming out, and hence there will be a decrease in the solubility of the gas in water. On boiling, water loses its taste. That is exactly what happens when the water is boiled, or when you drink a boiled water, it loses its taste. Why? Because the gases like oxygen or all which is present in the gas has escaped out, and hence the water tastes flat. Okay. So water contains soluble gases which contribute to the taste of the water. On boiling, the temperature of the water increases, thereby the solubility of the dissolved gases, air decreases, and the dissolved gases are hence expelled out. If the above water is once again shaken with air, the water gets back its taste due to the dissolution of air in water. So this is how it is going to be important, that the gases are going to be reducing the solubility when the temperature increases. Gases are more soluble in cold water than in water at higher temperatures. So soda containing carbon dioxide dissolves in water under pressure. So that's the reason that all the aerated drinks, the thumbs up and all, they always are served chilled. Why they are served chilled? Because when they are chilled, the amount of carbon dioxide which is released on opening the bottle is limited. As soon as it is heated, it is going to escape out faster. So a cold drink is served chilled so that the carbon dioxide is retained for a longer period of time, and we are able to have that tangy feeling for a longer period. When a soda bottle is kept at an ordinary temperature, it opens. When it is opened, the evaporation of the carbon dioxide is less compared to the similar chilled soda bottle, which on opening produces more effervescence. Thus, at low temperatures, the solubility of the gas is more compared to higher or ordinary temperature. Oxygen is more soluble in water than nitrogen, hence dissolved air in water contains higher percentage of oxygen, than ordinary air. So yeah, water will always contain more amount of oxygen than nitrogen present, because the solubility of nitrogen is less in water as compared to oxygen. So this gives you the explanation of how the solubility of the gases changes with the increase in temperature or pressure. Directly proportional to pressure, more the pressure, more solubility. Inversely proportional in temperature, more the pressure temperature, lesser the solubility. So this was about the solubility. So that is the thing what we discussed in this video. In the next video, we'll be taking up the crystallization and crystals formed by water. So that was about solubility.